Hi students, welcome to our physics class. Our chapter name is light. In the last few class we are discussing about this chapter and we discussed about mirror. In the first class we discussed about mirror and its plane mirror. Plane mirror. Within this plane mirror then we discussed about the convex mirror and concave mirror. Its uses and all the things we discussed, and also within this chapter we discussed about lens. So in the last class we discussed about what is lens, which are the different types of lens, all the things we discussed, and also studied as similar as this convex mirror we have convex lens. Here concave mirror, in the similar concave lens. And so within this topic we studied about the image formation. That means how the image is formed. Is it real, inverted, erect, all the things we discussed within this topic in the similar way using the experiment. With the lens, our candle, screen, all the things we are using and going to find what image will be formed on the screen. That means image formation. So we can say today's topic is this image formation using convex lens and concave lens. So we are going to discuss that. Before, we are going to refresh some of the things regarding this convex lens and concave lens. How is the diagram for this convex lens? We studied about two types of lens. One is this and another is this. What is the name of the first lens? Is it convex or concave? It is convex. Convex lens, and this is concave. Concave lens. And also we studied when the light incident on this convex lens, the light is getting focused on a point. Here we studied that when the light incident, it is getting away, spread. And we call this convex lens as converging lens. We already studied all these things. Converging lens. The reason is this, the light is focusing or converging to a point, and here it is spreading or it is diverging. So we can call this concave lens diverging lens. So these are the things we discussed in the last class. Now we are going to continue this topic first with this convex lens. Convex lens, and we are going to check how the image is formed. Is it small, big, same size, erect, virtual, all the things we are going to check. So our topic is image formation by convex lens. Image formation by convex lens. So this is our topic, and for this we need some of the experimental setup, and that is one, we want one candle. We want one candle and one screen, then one convex lens that is attached on a stand. setup. That means for the experiment we need one candle. What is this candle? This is object. This is our object. Object is there, and this is our lens, convex lens. And this is our screen. And the experimental procedure is similar as our mirror. That means we want to change the distance from this object and the lens, and we just check what image is there formed on the screen. Is it possible to focus the image on screen? One thing. Sometimes it is possible to focus the image on screen. In some time it is not possible to focus it on screen. And in some cases the image will be small, big, same size. All the things will happen. Now we are going to check. So the first position is this. Our object is very far from our convex lens. And when we are placing the object very far from our lens, how the image will form? What is the size? It is very simple. Our image is very small. Our image is very small. And the thing is this, we get the image on the screen like this. So is it erect or inverted? It is inverted. For this very small and inverted. And one thing is this, using this convex lens, it is possible to focus on the screen. That means, what about the image? Is it real or virtual? Obviously, is it possible to focus on the screen? Then the image is real and inverted. Real and inverted and real. So, when you are placing the object very far, you will get the image is very small and it is inverted and real. And we can say real means we can focus this image on the screen. And one thing is also there for the lens. That means when we are studying the mirror, the thing is this. Suppose this is our concave mirror and we are placing the object here, and our object is here, and where you are getting the image, you will get the image at the left side. You will get it on left side. But what about the lens? If you are getting it on the same side, for the convex lens, you want to remember the image formed will be there on the right side of our lens. That means, suppose this is our lens. So, the light will transmit through this or travel through this, and you will get the image on the screen. That means our object is here. Object is there at left and the image is there at right. So, it is on two sides. For this convex lens, when our object is there very far, you won't get the image on the same side of the object. So, here you just want to remember one thing. When the object is placed very far, your image is very small. One thing. The next thing is, you will get the image inverted and real. Real means you can focus it on the screen. And one thing is also there, you will get the image at the right side of our lens. Right side of the lens. This is the only thing. And now, as our previous experiment, we are going to move this candle from this point to this. That means little more near to our lens. So, this is the second position that I am moving our candle near to our lens. And now what happens to the size of the image? The image here is small. This is the first position. This is the second position. On the second position, our image is small. And again we are checking, is it inverted or erect? Here also you will get inverted and real. That means this case same for this and this. The only difference is with the size of the image. You will get the image on the screen and that is there on the right side of our lens. This is the second case. Now again for the third, we are moving our candle little more near to our lens. That means the third position. For the third position, again we are checking the image. At that time, you can see image on the screen. That means it is real. And also you can see it is inverted. And now, what about the size? Here for the third position, the size is same. Same size. That means the same size of the object. For the object and for the image, you will get the same size. So, for the third position, we can say it is same size. But this is same. Inverted, real. For the third position also, our image is inverted, real. But the difference is the coming with the size of our image. Here also, you will get the image at the right side of our lens. This is the third case. Now I am again moving this candle near to our lens. And now the same thing, same procedure, we are checking the size of the image and the nature of the image. Here you can see first our image is very small, then little more bigger, that means small. Again it is getting big and it is turned to the same size of our object. And now you can see our image is little more bigger than our object. That means large. Large image or enlarged image. Enlarged image. And here also you can see it is inverted and real. Inverted, real. That means all these cases are same. Only difference is with the size of our image. Now, fifth position. We are just again moving the candle near to our lens. Here, this is the fifth position. And when we are checking the size of the image, here you can see this is enlarged. Here it is highly enlarged. That means when our image is here like this, here you will get more bigger. That means highly enlarged. Highly enlarged. Here also for the characteristics or behavior of the image is same. It is inverted and real. Inverted and real. And the final case, that means when we are placing our candle very close to our lens. Now we are reaching on very close to our lens. Now what happens? Is it same inverted and real? One problem is there. Here, this is our candle, this is our sixth position, and I am trying, our screen is there at the back side of our lens or right side of our lens, and I am trying to focus the image on the screen. Suppose this is our screen, I am moving far, near, far, but still I won't get the image on the screen at this side. That means for this lens you will get the image at this side. That means the object and the image will be at the same side. That means for all these cases from 1 to 5 you will get the image produced at the right side of our lens. But for the last case, that means when our object is placed very near to our lens, it happens you will get the image at the left side. Here you will get the image at left side. Left side means, and your image will be like this. Is it inverted or erect? Obviously it is erect. And here we can say real if we are getting that image at this side. But here we are getting it on the left side. So it is not real, it is virtual. So only for the last case, only for the sixth case, that means when we are placing the candle very near to the object near to our lens, there we get image is erect and virtual. That is different from all these results. And what is the size of our image? It is enlarged. Here you will get the image enlarged, but the only difference is this: you won't get the image at the right side of the lens. Where you will get it on the left side. That means it is virtual and it is erect. That means straight image. So this is the image formation by convex lens. We can say here, for the size of the image, sometimes it is very small, then same size of the object, then enlarged, highly enlarged. Like you will get all size of image. That means the size of image is depending upon the position of our object. And here you want to remember all the cases rather than the 6. That means very near position. All other cases we get inverted and real image for the convex lens. But when we are placing the candle very near, what happens? There we get erect and virtual image. This is all about the image formation by convex lens. And there are some more things that you will study in your 10th standard. So just understand about this experiment and the size of image and the image formation. This is all about this. Now we can discuss about the image formation by concave lens. Image formation by concave lens. Concave lens. Here also we want one concave lens, one candle and screen. So we are placing our concave lens here on the stand. Always we want to place our object at the left side. And we are placing the screen. The peculiarity of the screen is this: we can move this from one place to another. For right, for left, for center, like all the things we can move this. So this is the experimental setup, same experimental setup. But for this concave lens, the thing is this: whatever the position of our object, you will get the same result. That similar as we studied in the mirror. So here you will get same result for all the position. That means when we are placing the object very far or little more near or very close, you will get the same result about the size of image, about the nature, all the things you will get the same thing. So the result is like this. The size of image is small image. The image is very small for all the position. When we are placing it here, when we are placing the candle here, when we are placing the candle here, for all the position you will get the small image. And the next is it real or virtual? For this concave lens, there is no real image occurs, there only occurs virtual image. That means for this lens we are saying it like this: we only get the image at the left side of our lens. That means if it is real, you will get the image at the right side of the lens. But here we are only getting the image at the left side. That means our object and the image on both sides. For the real image, you will be the object is at the left and our image is at the right. Here we can say for the concave lens, it is virtual image. It is not real. And also here we get erect. erect image. Our object is like this and also our image will be same, erect, not inverted. So these are the peculiarities of the image formed from concave lens. That means we can say the image is formed at the same side of our object. Object and image same side. That means the left side. Always our object will be at left, whatever be the lens, mirror, anything. And so we can say the image is very small or small and it is virtual image and erect. So this is all about the image formation by concave lens. So when you are studying this concave lens, you only want to study this. This is our experimental setup and whatever be the distance of the object from the lens, what lens? Concave lens, you will get small image which is virtual and erect. So this is all about the image formation of concave lens. Now we completed this topic and one thing you want to remember is this. Don't get confused with our convex mirror, convex lens and concave lens. The thing is this. For the concave mirror and convex lens, you want to look this. This is concave mirror and this is convex lens. Different things. These two are behaving similar. These two are behaving similar. Don't get confused. And here convex mirror and concave lens. So this convex mirror and this concave mirror are behaving similar. That means different types of mirror and lens are same. Don't think that this concave mirror and concave lens is similar. They are not similar. And we studied about the size of the image. For this concave mirror and for the convex lens, we get very small image, enlarged image, same size of image. That means here our image is having different size. So we get small, same size and also enlarged image. Here for this concave mirror and for the convex lens you get same size, small size and enlarged. But when we are thinking about the convex mirror or the concave lens, you will get small image for that. And here you will get inverted and real generally. Inverted and real for general cases. And when we are placing our object very near to the concave mirror or our convex lens, what you get? You will get another result, that is erect and virtual. This is for the very close position of our object to the mirror and lens. So you will get inverted real for all the cases and here you will get different result. But here you only get one result. That means all you will get erect and virtual. So you want to remember this table. That means for all the cases this is same. That means for the concave mirror and convex lens same result. For the convex mirror and concave lens same result. Don't get confused. You want to study it properly. So this is all about our today's class. Now I am going to give you one simple work that is actually we will discuss in the next class. So you just want to practice it and come to my next class. That means just take one cardboard. Just take one cardboard piece and cut it in circle. Then mark the center and split it into 7 pieces. And give colors violet, indigo, blue, green, yellow, orange, red. That means you just want to take one circular cardboard piece, then draw lines and you want to take 7 parts, and this is our Vibgeo. Violet, indigo, blue, green, yellow, orange and red. You just give the colors and then at the center just put one hole and some sort of stick or something. Take and rotate this. You want to give the colors and rotate. And you want to observe what you can see here when you rotate it in very speed. When you rotate it, what you can see. That is your simple activity. Just do it from your home and come with the result for the next class. So, this is all about today's class. We will discuss this in the next class. And some of the things are left in this chapter. I think we can conclude this in the next class. So, this is all about today. We will meet in the next class.